In type 4, we will apply combinations to people and distinct objects, not to letters, but combinations to people and distinct objects. And the kind of conditions that we will have are at least, at most, no more than, fewer than. Okay, so you might find some repetitions, as in you might find this similar to maybe type 3 or type 2. Okay, so don't worry about that. Just focus on the concept. Okay, so I've taken out some questions which we are going to solve, and let's get to work. So here's a question from past papers, which we're going to solve. Let's see what this says. A committee of 6 people, which must contain at least 4 men and at least one woman, is to be chosen from 10 men and 9 women. Find the number of possible committees that can be chosen. So the condition here is that there's got to be at least 1 man, at least 4 men, and there's got to be at least 1 woman. Okay, so now what we have to do is we have to come up with different possible ways that we can meet this condition. Okay, so here's how you should approach this question. Write down the total number of men that you have. So you have 10 men. Write down the total number of women that you have, and that's 9. Don't forget that the total number of people that you want, okay, so no matter how you divide between the men and women, the total must be equal to 6, meaning the number of men plus the number of women must be equal to 6, okay? So one possible way is that we have 4 men and 2 women, correct? 4 men and 2 women make a total of 6, so that's correct. Okay, we'll figure out how we can work this out. What's another possibility? What's another possibility? How many ways can I fulfill can I meet the condition 5 men, 1 woman? That's correct. We can have 5 men and 1 woman. And once again, the total is 6. Okay, so this is another way. Now let's work them out. How do you select 4 men from 10? That's 10C4. How do you select 2 women from 9? That's 9C2. How do you select 5 men from 10? That's 10C5. How do you select 1 woman from 9? That's 9C1. That's it. Work this out, add them up, get your answer. Okay, so 10C4 into 9C2, that's equal to 7560. Then similarly, 10C5 into 9C1, which is equal to 2268. Let's add them up. 2268 plus 7560, which is equal to 9828. All right, so fairly easy, but we will obviously make it more complicated gradually. Let's do another question. Here it is. Now you will notice that the backstory in a lot of cases is just irrelevant. Okay. So I think I told you guys before also that the backstory is there to sometimes confuse the students. Okay, I can't really think of any other reason for it being there. And sometimes I think the backstory is there so that students realize that this has real world applications as well. ठीक है, इसीलिए देते हैं बैक स्टोरी, और इस सवाल में बैक स्टोरी देने का कोई मकसद नहीं है, ताकि और basically when you realize that it has real world applications, you'll naturally develop better problem solving skills. ठीक है, so ये 3 reasons हैं why you have such a huge backstory in questions like these. Okay, so let's solve this question. Let's see what this says. Mary saves her digital images. I hope you guys can see my screen. Yeah. So Mary saves her digital images on her computer in 3 separate folders named family, holiday, and friends. Now you might remember that we solved a question similar to this, but we focused on a specific part. Okay. Then the question says her family folder contains 3 images, her holiday folder contains 4 images, and her friends folder contains 8 images. All the images are different. Find the number of different ways in which Mary can choose 6 of these images if there are at least 3 images from the friends folder, at least 1 image from each of the other 2 folders. Okay. So how many marks is this? It's a 4-mark question. So sit back, relax. That's how you should approach this question. Okay, no need to panic, no need to rush into it. I know your time is of the essence, but don't waste any time. Iska matlab nahi hai that you start sipping coffee or something. Just make sure that you're tackling it patiently. So we have, how many folders do we have of family. How many images do we have of family? That's 3. So 3 for family. Okay. How many images do we have for holiday? That's 4. So 4 is for holiday. And then how many images does the friends folder contain? That's 8. So friends folder mein aapke 8 images. Okay, so far all I've done is just written the information. Remember that the total, no matter what happens, must be equal to what? Must be equal to 6. Why? Because that's what the question says, that Mary can choose 6 of these images. Okay, so that's what she does. She can choose 6 of these images. Now let's look at the condition. The condition is that there are at least 3 images from the friends folder and at least 1 image from each of the other 2. So that means friends mein se 3 honi chahiye aur baki 2 mein se kam 1 honi chahiye. So here's one way we can do it. We can have 3 images from the friends folder, all right? And we can have perhaps 1 image from the holiday folder. Okay, now the total is what? The total is 4, and 2 from the family folder. Kya khayal hai? Is that possible? At least 3 from friends and at least 1 from the other. Now, how many other ways can we do that? We can have 3 from friends. Okay. We can have 2 from holiday and 1 from family. Make sense? Any other possibility that you can think of? This here also, by the way, the total is 6. Any other possibility? Think about it. 4, 1, 1. That's correct. 4 from friends, 1 from holiday, and 1 from family. Any other possibility? No, there isn't. There is no other possibility. Okay, now and what's the total here? The total here is 6. Now let's work them out. So how do you select 3 objects? How do you select 2 objects from 3? That's going to be 3C2. Okay, how do you select 1 object from 4? That's 4C1. And 3 objects from 8? That's 8C3, whatever that's equal to. Then 3C1, 4C2, 8C3. ठीक है, ये column सिर्फ हम इसलिए लिखते हैं so that we can add and see if the total is equal to 6 or not. And then finally 3C1, 4C1 into 8C4. Okay, so let's see what do we get. So 3C2 into 4C1, which is 4, into 8C3, so that's equal to 672. Okay, and then 3C1, which is 3, into 4C2, whatever that is equal to, into 8C3, that is equal to 1008. And the last will be equal to 12 into 840. There you go. Okay, so let's add them up. Let's see what we get. So 1008 plus 672 plus 840, we get 2520. So 2520 is the answer. All right, now take a good look at it. Let me know if you have any questions. And if you don't, I'm going to give you guys a question to solve. Here it is. Here's the question that I would like you guys to solve. Okay, so इसमें भी हमें यही करना है. We need to come up with all the possible ways that we can achieve or we can meet the condition that the question has given. There are 10 spaniels, so I'm going to write down spaniels, and in bracket I'm going to write down 10. There are 14 retrievers, so just an R, and in the bracket 14. Okay, you can write the number first and then whatever it is, doesn't really matter. And as far as the poodles are concerned, there are 6 poodles. 7 dogs are selected, so that means in the end, make sure that the total, irrespective of how you divide them, the total must be equal to 7. Okay, so I always prefer making a column for total also, so that way I can constantly keep track whether the total adds up to 7 or not. Achha, the breakup is that there must be at least 1 spaniel. Okay, so there's got to be at least 1 spaniel, at least 2 retrievers, and at least 3 poodles. Okay, so you can write this also to make your life easy. So let's say that we have at least 1 spaniel, at least 2 retrievers. Then how many poodles do we need to make a total of 7? We need 4 poodles. Okay. Achha, what else can we do? Let's increase the number of spaniels to 2. Let's keep the number of retrievers to 2. And that way we will need to have at least, that way we need 3 poodles. So that way the total is once again 7. Any other possibility? So what if we have 1? Okay, I've already considered 1, 2, 4. So, but what if I have, let's say, is there another possibility? I think we can do 2, 2, 4. No, that won't work. 3, 3, 1. Yeah, that's correct. So we can have 3 spaniels. We can have 3. No, wait. Yeah, that's not going to work. 1 spaniel, 3 poodles, and 3 retrievers. Yeah, that makes 7. So this way they're all, we have met all the conditions. Yep, that's correct. Okay, and then you can find out, you can find out the way to do that, as in this would be equal to 10C1 into 14C2 into 6C4. Okay, and then all of this. So the final answer will turn out to be 168,350. Okay, so good job. If you guys can do questions like these, that means you now have a good grip on permutations and combinations. Okay, so we're going to increase the difficulty level a little, and we are going to solve a slightly more complex question. And here it is. So it says a different committee of 6 people is to be chosen from 6 men and 8 women. 3 of the 6 men are brothers. Okay, so amongst the 6 men, there are 3 brothers. Find the number of ways in which this committee can be chosen if there are no restrictions on the number of men and women, but it must include no more than 2 of the brothers. So that means we can't have all 3 brothers. Okay, we can't have all 3 brothers. We can have one of the 2. Okay, it says it must include no more than 2 of the brothers. Okay, so that means we can have 2, we can have 1. Okay, now let's solve this question. Let's say that in this committee of the 3 brothers we just include 1. ठीक है, so I hope सवाल सबको समझ आ गया. इन 6 men में 3 भाई हैं. ठीक है, अब हमें सिलेक्ट ऐसे करना है कि 3 भाई में से 2 से ज्यादा नहीं होने चाहिए. Okay, so of the 3 brothers, you should not have more than 2 of the, you should not have more than 2 brothers. Okay, so one way to do that is if we select just the one brother. Okay, one way to do that is if we select just the one brother. Okay, now let's look at the number of men that we have. We have 6 men. Okay, now if I've committed that I'm going to just select one brother, so let's select that brother immediately. Okay, so let's select that brother immediately, and the way to do that is we will select that one brother from how many? We'll select that one brother from the 3 brothers that we have. Okay, so if I have to select the one brother, okay, I have 3 options. So that would be 3C1. Okay, so I hope you guys are following. There are 3 brothers to choose from, and we have to select only one. So that would be 3C1. Okay. Now, if you think about it, how many men are we left with? Acha, ek kaam karte hain. Just a second. Let's split the number of men in such a way that we look at the brothers separately. So these are the 3 brothers separately. Okay, and these are the other 3 men that we have separately. Amongst these 3, okay, from these 3, we need to select only one. And the way to do that is 3C1. Okay, the way to select one brother from 3 is 3C1. Okay, so there are 3 brothers and we're only selecting one. Now, how many men are you down to? You're down to 3 men. Okay, and don't forget that as far as the number of women are concerned, there are 8 women. Okay, so now you still have to complete the group. You still have to make the committee of 6 people. So that means you have so far just selected one person. Okay, you've so far just selected one person. How many more do you have to select? You have to select 5 more. And the question is, where will those 5 more people come from? Those 5 people can come from the 3 remaining men or the 8 women, where there is no restriction. Okay, so the remaining 5 people can come from the 3 remaining men. Why? Because we've already excluded the brothers. Why have I subtracted 3 from 6? So that no other brother ends up getting selected. We've selected one brother. Now we have to make sure that no other brother is selected. So that's why we remove these 3 brothers. We're going to just put them aside. And we're going to select from the remaining men and the remaining women, which happen to be 11. And how many are we selecting? We're selecting 5 to make a total of 6. Okay, so let's work this out. This would be equal to 3C1 into 11C5. Now, it's not the end of the question. There are more possibilities that we have to consider, but I'd like to pause here and ask you guys if you have any questions. Okay, so I'm going to pause here. Let me know if you guys have any more questions. Will we multiply by 3 now? No, we're not going to multiply by 3 now. I'll show you why we're not going to multiply by 3 now. Don't worry about what we're going to do next. Just let me know if you have any questions so far. Okay, so I'm judging by the silence, no questions. Now let's select 2 brothers. Okay, let's select 2 brothers. So once again, we have 6 men and 8 women. Okay. So there are, amongst the 6 men, there are 3 brothers. Okay, and from these 3, we only have to select 2. Okay, so these are the 3 brothers, and we only have to select 2 of them. How do we do that? That would be 3C2. Okay, so from 3 objects, from 3 people, you have to select 2, 3C2, pretty straightforward. Now the question is, what are we left with? So we are now down to, once again, 3 men and 8 women. Now the remaining people will come from 3 men and 8 women. That means there's no restriction. So we can just make one group. So that would be 11. But the question is, how many more people do we have to select? We now have to select 4 more people. Okay, so we have already selected 2 brothers. That means we've made, of the 6 people committee, we've selected 2. Now we're down to, we have to select 4 more, and we have 11 people left to do that. And that would be 11C4. So 3C2 into 11C4. Let's see what that is. That's equal to 990. Is that it? You think there is another possibility? Or do you think that's it? Do you think there's another possibility, or do you think that's it? Very good. Very good. Exactly. The question said that it must include no more than 2 of the brothers. So that means that could be 2, that could be 1. It could also be 0. Okay, 2 से ज़्यादा नहीं होने चाहिए ना. That means 2 से कम तो 2 या 2 से कम तो हो सकते हैं. So 2 हो सकते हैं, 1 हो सकता है, 0 भी हो सकता है. Okay, the question said no more than 2 of the brothers. So that means you could have 2 brothers, perfectly all right. You could have 1 brother, perfectly all right. You could have 0 brothers. That's also possible. So let's consider that. Let's consider the third and the final possibility, which is that we have 0 brothers. 0 brother or 0 brothers, whatever you want to write it as. Okay, so that's pretty straightforward, because what we're going to do now is we're just going to remove the brothers from the men. Okay, so these are out. Now we have to select we have to select 6 people. Okay, we're not going to remove them because we've selected them. We're going to remove them because we don't want to select them. Okay, the number of women are 8. Now we have to select the remaining 6 people because we haven't selected any one of them from the remaining 11 people. And how can you do that? That's simply 11C6. Let's see what that's equal to. 11C6, that's equal to 462. Let's add them up. See what do we get? 462 plus 990 plus 1386. That's equal to 2838. Okay, so what's the lesson here? The lesson here is you got to make sure that you're reading the question very carefully and you don't miss out a possibility. Okay. All right. Now, here is the following question is a slightly unorthodox question. Meaning in the sense that you don't get questions like these too often, but it's a good question nonetheless. So here it is. This will be example number 5. The last example from this type, and then we'll do the final type. Achha, Ismail, let me tell you that because I have taken specific parts, so this part is completely irrelevant. Okay, so all this information is irrelevant. This is for a separate part of this question. Okay, so this is the relevant part. Now, I will give you guys a couple of minutes. It's a 3-mark question, so I'll give you 3 minutes, 4 minutes, to work this out. When you have the answer, please do share it with me, and then we will discuss and move on. Okay, so 511 is the correct answer. Now, the reason why I told you that this question is slightly unorthodox is for the following reason. You're not given the number of, yeah, exactly. You're not given the number of books he can select, because he can select from 1 to all of them. Okay, so he has 9 books, And notice the question says that he can take any number of books ranging from just 1 to all of them. So that means, what if he takes 1? How many ways can he take 1 books from 9? That's 9C1. What if he takes 2? So that's 9C2. Now, because these are different possibilities, it's not the same. It's not like it's the same. We're within the same condition. No, these are separate conditions. Okay, these are separate ways of meeting the restriction that's given in the question. So 9C1 will be separate, 9C2 will be separate, 9C3, and then we will do this all the way to 9C9. Okay, you add them up, 511 is the correct answer. Okay, good job. Now, the last and the final part of combination, basically the only. Okay, so once again, we'll start easy and gradually increase the difficulty level. So for this, we don't have to like sit down and learn a new concept. It's pretty basic. So 9 people are to be divided into a group of 4, into a group of 3, and a group of 2. In how many different ways can this be done? All right, pretty simple. So let's say we have to make a group of 4. Okay, so first we're making a group of 4. 1, 2, 3, 4. And then we're making a group of 3. And then we're making a group of 2. Okay. So when we're making a group of 4, we have 9 options to choose from. So that means that can be done 9C4 number of ways. Then we have to make a group of 3. Now notice that we had 9 options to choose from. 4 people have already been put into a group. That means now we're down to how many? Now we're down to 5. Okay, and we have to, from these 5 people, select 3. So that would be 5C3. Now you remove 3 from 5. That means now you're down to 2. And the remaining 2 people have to be put in a group of 2. And the way to do that is 2C2. Okay. So 9C4 into 5C3 into 2C2, whatever that is, that's the answer. 9C4 into 5C3 into 2C2 into 2C2. That's the answer, which is equal to 1260. ठीक हो गया? अच्छा. अब let's do another question. And here it is. This is slightly more complex. Let's see what this says. So this says the group of 8 friends travel to airport in 2 taxis, P and Q. Each taxi can take 4 passengers. All right. The 8 friends divide themselves into 2 groups, one group for taxi P, one group for taxi Q, with John and Sarah traveling in the same taxi. Find the number of different ways this can be done. Now, because there's no new concept essentially that you have to learn in order to solve questions like these, I would like you guys to try this question. Once again, I'll give you 4 minutes to solve this. And as soon as you're done, then I will solve it myself. Okay, so go ahead, give it a shot. When you have the answer, do share it with me. Very good. So let's see why 30 is the correct answer. I'm going to solve it now. Pay close attention. So we have a group of 8 friends who are traveling in 2 different taxis. The taxis are called P and Q. Okay. So let's say this is taxi P. Let's say this is taxi Q. Okay. Now, the condition is, the only condition, other than the fact that they should obviously divide into 2 groups of 4, is the fact that John and Sarah must be traveling in the same taxi. And the question doesn't specify which one. Okay, that's the only condition. They should be traveling in the same taxi. So that means if, let's say, I put John and Sarah together in taxi P, that means now we had 8 people. Okay, so there were 8 friends. John and Sarah are 2 people. So now we're down to 6 people. That means the remaining 2 people can be chosen from the remaining 6 people. Okay. And for the other taxi, there are 4 people left, and we have to choose all 4 of them. So that would be 4C4. Okay, so 6C2 times 4C4. But here's the thing. Here's the thing. There is no such thing where the question says that John and Sarah could be in taxi, have to be in taxi P only. They can be in taxi P, they can be in taxi Q also. Okay, so that's why we multiply by 2. So what's this 2 for? Let's see. This 2 is that John and Sarah in P and John and Sarah in Q. Okay, so that's why we multiply by 2. And what do we get? We get 30 as a result. Okay, so I hope you guys are following. Now let's move on. And let's do another question. Okay, so this is perhaps the last question that we're going to solve. Also, another unorthodox question. It's a 5-mark question. So when you see a 5-mark question, that means it requires a decent amount of working. Now, what example number is this? This is example number 3. Another thing to keep in mind is that, for example, if you go back to example number 1, ठीक है, तो एक चीज का आपने ख्याल रखना है कि we did 9C4 into 5C3 into 2C2. Okay, which suggests that you should first divide them into a group of 4, then divide them into a group of 3, then divide them into a group of 2. The order doesn't make a difference. Meaning that if I had done, let's say if I had done 9C3 first, and then I had done 6C4, meaning first I divide them into a group of 3, then 4, and then 2. Notice what do we get? We get the exact same answer. So 9C3, let's work it out. 9C3 into 6C4, 6C4 into 2C2. इधर भी हमारे पास क्या आ रहा है? हमारे पास 1260 आ रहा है. Okay, so even if let's say you first divide them into a group of 2, okay, and you then divide them into a group of 4, so that would be 7C4, and you then divide the remaining 3 people into a group of 3, then also you'll get the same answer. 9C2 into 7C4 into 3C3. So you get the same answer, 1260. Okay, so what I'm trying to say over here is that the order in which you make the groups does not matter. Okay, so आपने जिस order में groups बनाने आप बनाए. आपने पहले 4 का बनाना है, फिर 3 का बनाना है, फिर 2 का, या you want to shuffle it up, it doesn't really make a difference. Okay, now here's another question. Since we're short on time, I'm going to solve it myself. And here is how we're going to do it. 9 different fruit pies are to be divided between 3 people so that each person gets an odd number of pies. Okay, so 9 pies, each number must get an odd number of pies. So let's say the 3 people we're talking about are A, B, and C. Okay, now let's see one way that we can fulfill this condition. Okay, so each person gets an odd number of pies. That's the condition. And let's write down one way that we can fulfill this condition. So 3, 3, 3, is that possible? That is possible. 3, 3, 3 means every person, the total is 9, and every person gets an odd number of pies. Now, how can we figure this out? This can be done 9C3 because you have 9 pies. So you first, take 3 out, and then from the remaining 6, you take another 3. And then from the remaining 3, you take the final 3, whatever that is equal to. Okay. Any other possibility that you guys can think of? Any other possibility where each person gets an odd number of pies? 153. Okay. Now here's the thing. 153 is absolutely correct. But how do we work this out? 153 means 9C1 into 9 minus 1, that's 8. 8C5 into 8 minus 5 is what? 8 minus 5 is 3. So that's 3C3. Now, there are so many other ways that we can shuffle 153. Okay, and we have to consider that. So A getting 1 pie and B getting 5 pies and C getting 3 is definitely not the same as A getting 5, B getting 3, and C getting 1. Okay, and just like that, A getting 1, B getting 3, and C getting 5, and just like that, 5, 1, 3. Okay, and what else can we consider? We can consider 3, 1, 5, and 3, 5, 1. Okay, so instead of working all these out separately, what we can do is, how many possibilities do we have? We have 6 possibilities, right? And why do we have 6 possibilities? That's the question. Why is it that we have 6 possibilities? The reason why we have 6 possibilities is because of 3 factorial. Okay, so this is a bit of combination and a bit of permutation as well. Why? Because 153, because we're talking about number of pies a person is eating. Okay, so A eating 1 pie, B eating 5, C eating 3 is definitely not the same. हम ये तो नहीं बोलेंगे ना एक ही बात है भाई तुम एक खाओ या मैं 5 खाऊं तुम एक खाओ या तुम 5 खाओ मैं एक खाऊं, एक ही बात तो नहीं, ठीक है, अलग-अलग बातें हैं. So we have to consider all these possibilities. Now we know that if we do it manually, it's going to be a lot of work. So instead, what we're going to do is we're just going to find out one possibility and multiply it by the number of arrangements. And why does it not make a difference? Why can I do multiplied by 3 factorial? Because we just saw that if I do 9C5 into 9 minus 5 is 4, 4C3, and then into 1C1, it's going to give me the same answer as this. Okay, because it's going to give me the same answer as this, so I don't need to consider every single possibility the same. So that means I can just find out one possibility and multiply it by the number of arrangements. Okay, and just like that, there's more. There could also be 117. Okay, so how many ways can you arrange 117? First, let's find out how many ways of the pies can be divided. So that would be 9C1 into 8C1 into 7C7. Now we know that 117 can be arranged 3 factorial divided by 2 factorial number of ways. Okay, so altogether, basically 3 ways. And what are those 3 ways? Those are 171 and 711. Okay, so instead of working them out one by one, we can just multiply it by the number of arrangements. Okay, so this turns out to be 3024. And this turns out to be 1680. Okay, here we don't have any other arrangement. And finally, this turns out to be 216. Now you add them up, you get the final answer, which is 4,920. There we go.